Recording started.
Talk shoes. Recorded live.
Good morning, good evening, wherever you may be across the nation or around the world. Once again, you are listening to the VMware Communities Roundtable podcast. This is podcast number 534. My name is Eric Nelson, and with me, I have my regular co-host, Matt Longa. Matt, how you doing today?
Eric, I am well. It's somewhat rainy and overcast day in central Pennsylvania, but no locusts as of yet for 2020. So I can't complain. But how are you, sir? How are things out in the Bay? What's the color of the Bay? And speaking of bugs, how is the VMTN upgrade going along?
Oh, well, thanks for asking. First, we'll hit the color of the Bay. The color of the Bay is dark gray. It is winter here in California. Big cold front moved in last week, and it has been cold. I almost froze my new orange plant that I grew from seeds. It has been chilly, and we got frost last night. So welcome to wintertime. We're only maybe 6 weeks away from Christmas. Can you believe that? So Matt, it has been cold and miserable here in the Bay Area. So we're catching up to Michigan and Pennsylvania and all those cold places. So that's good. When we get to the VMTN bug upgrade, VMTN has been going great. We upgraded the community platform. So if you haven't visited vmtn.vmware.com or the communities.vmware.com, go check that out. We upgraded the whole platform. It has been fun to do that. We upgraded 5 million users, multiple millions of posts got upgraded to a new platform called Chorus, and it has been going well. We've gone from having an average of 100 posts a day to over 400 posts a day. So we've seen a 4x improvement just in the last 4 days since we've upgraded, and the performance is much, much better. We're still indexing the site, but page loads have gone down from 7 seconds a page and even higher when you're editing down to a comfortable 2 or 3 seconds. And we expect that to improve. So all in all, Matt, thanks for asking. It has been a very nice and pleasant upgrade. Lots of things that we've corrected throughout the weeks, and the team has been on it, listening to people on the boards when they have questions or asking. We've been engaging with them and have got a lot of good feedback, and we're doing updates every day. So all in all, a fun upgrade for sure. On the
Congrats to you and Jenny and the rest of the team. Sounds like it went as well as possible could be.
Yeah, absolutely. It's thanks for saying that. And it has been going, and everybody's been working a lot of hours to make that happen. On the show today, it is networking week. Everybody knows that we're doing a big networking launch next week, November 16th, 2020. So if you haven't registered for that yet, you should absolutely go do that. It's all about networking and how VMware is going to reinvent networking with software-defined networking. And if you haven't heard, Project Montery, putting ESX on a network controller. So man, networking is moving. Security is all about security and multi-cloud networking and the endpoints. So there's going to be a really cool presentations for this launch. I think it's an international launch, so it's going US, Asia, and Europe, much like VMworld did. And I did get a sneak peek on the video, and I would say that it's going to be really worth your time watching. I think it's only an hour long, but go register for that, and you'll definitely want to get it because it does address Project Monterey, and putting ESX on a network controller is pretty cool. So go register for that. You can register at vmware.com. And on the show today, we're going to be talking about networking, and we have with us a guest, Mervyn Fernandes. Mervyn is worked at Cisco for many, many years, and so he's come on to give us kind of some historical perspective of how the industry is changing from hardware and Cisco switches into SDN. So we've got Mervyn Fernandes on the call. We'll get to him in a minute and let him do some introduction to himself. But before we do that, maybe we'll get to some news. So Matt, what's happening with VMUG?
VMUG. So November 24th, the VMUG Virtual UserCon for the UK will be, again, November 24th. I believe the keynote there will be by Joe Begley. So Joe is the VP and Chief Technology Officer for EMEA, and really looking forward to that event. Also, in other news, vExpert applications for the latter half of this year will open up on the 20th, 11/20. So for vExpert applications. So keep that date in mind.
Very nice, very nice. So vExpert's opening up. Corey's been dealing with the VMTN upgrade, so he can't be with us on the show today, but I'm sure he'll be busy with vExpert applications as well. So I'm looking excited to that. So okay, let's spend a little bit of time talking about networking and introduce our guest, Mervyn Fernandes. Mervyn, why don't we always do this on our community show? Since we all are about community and learning new people and meeting new people, why don't you give us a little elevator pitch? Who are you, and give us the arc of your career. What have you worked on with regards to networking?
Hello, hello everyone. It's Mervyn Fernandes. As Eric mentioned, I was with Cisco for the most part of my career, 22 plus years. And then I went into semi-retirement, but I essentially worked as a consultant on contract at different companies on different networking projects. And for the most part, it was either infrastructure related or just migrations or new network builds based on next generation data center architectures or cloud-based solutions. I have both a traditional networking background as well as a next gen background in terms of how the network has evolved over time. And we can talk about, we'll briefly start with just traditional networking to give you guys a baseline in terms of concepts, and then move from that to what we have today in terms of next gen regarding software-defined networking that Eric mentioned, as well as other features, solutions that are in the industry today.
Right. Well, thanks for the introduction. It's always good to, meet people that have been through it. I think that over the years, when we're talking about networking and IT gear and the data center migration, over years, me and Merv, we've had conversations about, the arc of where networking is going. And it's interesting to start at the beginning where it was all, look at Sun Microsystems and switches, and when they invented TCP IP and switches and all of that, right, which was all physical networks, and then the arc of next generation switches, right? So we started networking, well, the history of networking, when, TCP IP and that invented an ARPANET, I guess some of those guys started building that. And then we've gone to hardware, we went into hardware switching. And I guess from a history perspective, how much do you think the industry is still in hardware switches, right? So give us a little sense of the history of hardware, in networking, and then up to 2020, what percentage of the world do you think is still stuck in that physical switch mentality, given that you worked at Cisco and watched Cisco's kind of moving their customers to software defined versus not software defined?
Yeah. Traditional networking, as I called it, was based on physical switches, and this concept of the iOS or network operating system that ran on the switches. It was essentially the control plane and the data plane that was implemented on the one switch. And just from a physical hardware perspective, in terms of speeds and feeds, when we first started many years ago, fast Ethernet or 100 megabits per second was enough speed at that time. But what we've seen over the years is an evolution to gig E. And now what you see is 10 gig, it's actually 25 gig, and there's 40 and 100 gig switches. So the capability of these switches has increased tremendously. But the interesting part is the cost for providing these higher speeds is actually quite reasonable, hasn't changed that much. So from a physical hardware perspective, the switches actually perform more, but the architecture has changed in the sense that they've introduced what's called software programmability into these switches, as well as this move, or migration towards a software-defined network. So the traditional network that followed the OSI model, that's still there and it exists. And there's still layer 1, for example, where you actually go from like 10, 25, 40, and 100 gig. And the cabling and infrastructure that you can put in place to provide the switching at layer 1. And then as you move up the stack to layers 2 and 3, that's where you see all the changes and evolution. When we first started, we had the physical switch, non-virtualized, with multiple NIC cards that essentially connected to a switch. And then at layer 2, you essentially deployed VLANs to give you the separation at layer 2. And we refer to as broadcast domain containment at layer 2. So that's still there, spanning tree and VLANs at layer 2. And then quickly, as you move up to layer 3, you have what's called layer 3 routing protocols. And for those we refer, that's typically like IP routing protocols, such as BGP, OSPF. And that's there as well. But the architecture has changed from the traditional sense where we used to build a 3-tier architecture with an access layer, a distribution, and a core, to a 2-tier architecture, which we call today as a spine leaf architecture. Now, what's interesting about this is there's still layer 2 and there's still layer 3. But what's changed here is this concept of virtualization and software-defined networking that's been introduced. So in the case of VMware, for example, VMware went out, VMware was essentially in the server virtualization space. And then with the acquisition of Nicira many years ago, that's where they introduced some extensions to layer 2, which you probably heard of, and which we refer to as VXLAN, virtual extensible LAN. And that's what's that started the revolution or evolution to next generation networks, in the sense that layer 2 changed, and by leveraging VXLAN, it allowed you to extend your layer 2 networks now across much larger geographies, either within the data center or across data centers. And what they've done is all of the switch vendors, Juniper, Arista, Cisco, they've all incorporated VXLAN into the switches. And for the most part, it's done in hardware. And that actually led to the evolution of the network from a layer 2 perspective to give you this layer 2 extensibility for your network.
In software.
In software.
Right.
In VMware's case, you have what's called the NSX controller. And with the NSX controller now, you have the separation of the control plane from the data plane, where the NSX controller is essentially the central control point with data forwarders that you implement elsewhere in your network. But in this case, the NSX controller provides the programmability to the data forwarders that you implement in each server. And in this case, it could be a server running standard like ESX type functionality, as well as the data forwarding piece where it communicates with the NSX controller. So similar concepts have been deployed on the networking side, where with Cisco, Juniper, and Arista, they all have an external controller as well, but it's more an external controller from a networking perspective. And with this new evolution, you hear these new terms called the overlay and the underlay of the network. So with the overlay and underlay concept, the underlay actually refers to the underlying plumbing of the network. These are the switches that do the traditional forwarding of packets. And then in the case of the VMware solution with NSX, you build like a VXLAN overlay on top of, like, for example, a Cisco underlay or physical network, or it could be a Juniper, or it could be an Arista. It doesn't matter.
Right. So the underlay is still done in the hardware space, right? And then the overlay is where you have the SDN software layer come in that layer 2, and then, you know, build out a virtual structure for that.
That's right. So think of it as, you know how you actually have layer 2 VPNs, for example?
Huh.
So these are layer 2 tunnels that you're actually building using VXLAN between two endpoints that need communication. So for example, let's say you want to go between a finance server and let's say an HR server somewhere else. Traditionally, you'd have to go up to, you would actually go up to the physical switch and then route between those two VLANs. But now with this new solution, you can actually build a VXLAN tunnel between the two servers and have that done through NSX, or have that done through an external controller from either Juniper, Arista, or Cisco.
Right. And where VMware comes in is the NSX solution for that, right? And
That's right.
runs on top of that.
That's right.
Yeah. Talk about charging for a second, like the cost of this stuff, right? Like I know that there is the physical port cost that the switch providers provide, but then there's generally a cost at the, you know, building this layer 2 extension, right, in the software space as well, right? Like this is, I know VMware charges for this stuff, right?
It does, and I think that's all part of the evolution towards charging and software-based charging solutions. So now, uh, with software now, you pay a licensing fee.
Right.
And depending on the number of connections you require, as well as the feature itself,
Right.
you would pay either a monthly or an annual cost.
So you get into the SaaS sales of network connectivity from a software perspective, right? And you buy the hardware per port, maybe, you know, down below layer 2 or up to layer 2, you're buying the hardware for that. Then you're paying software charges on that extensive.
Yeah. In layman's terms, in the VMware model, you have like your gold, silver, and bronze. Bronze being, let's say, you just have a need for 100 connections, then you would just get the bronze solution. If you needed more, then you go up to the silver or the gold.
Right. Okay.
And then with the existing infrastructure from an underlay perspective, it's just your existing cost for ports on your physical switches. So the physical, the servers running VMware would connect up to the switch, the upstream switch.
Right.
And that would be at 1040 or 100. While on the server side, I think it would probably be 10 or maybe 40, depending on advancements on the NIC cards. And then you would just build your traditional network to give you the end-to-end connectivity, either within the data center or within your campus. And then when you're going across campus sites, you would just do the VXLAN layer 2 extensions now.
Now, the interesting thing that's happened and why we're talking about this today is that we are doing this network day, Network for a Future, where we're highlighting kind of this architecture, but then we're looking at the security implications of this. So VMware has gotten into the security business as well, where we're starting to do network security in that layer as well, where we're managing endpoint connections, right? And traffic that's going from these endpoints. So we've actually started to look at layering in security into that fabric as well. Right, into that tier 2 extension, right? Which is interesting. Yep.
Yeah. So what you're actually referring to is kind of what we call network function virtualization. So in the case of VMware and other server vendors, You can implement security as a software feature, a function in the server. You can do routing, for example, it's called distributed virtual routing in the server as well. So that's the solution or direction from a VMware perspective, where not only can they do the NSX piece, where you're actually deploying the overlay, at the same time, I'm going to also give you the firewalling piece. I can give you the IDS or IPS, intrusion detection, as well on the server. If you wanted IPsec, for example, they could probably deploy an IPsec tunnel to encrypt your data,
Right.
that sort of thing.
Yeah.
It's a different model where it's still NSX based. It's controlled from the external controller. You build your endpoints between the servers, depending what the requirements are, whether it's just layer 2 extensions using VXLAN. If you want to add IPsec on top of that, you can certainly do that. What you have to remember, though, is there's issues with scalability now. And as you get into large cloud-based networks where you could have, 20 or 30,000 nodes within your network, that's where you have to build your network properly, in the sense that there's scaling limitations per NSX server. So as long as you follow the guidelines and recommendations from NSX or a Cisco or a Juniper or an Arista, you can build your network that allows you to scale to these large numbers.
Right. Okay. So that's interesting. So we got security layered in to the overlay offering. The other thing that we're seeing is application control endpoint management, right? Where modern apps, where you're having microservices spin up in different places, and then managing endpoint connections, that also folds into managing that traffic in the overlay software, right? Which is a third place that VMware kind of inserts itself. One is in the overlay with NSX. Two is the security, extensions in that overlay, and then three is modern apps endpoints, whether it's Kubernetes or other applications that are running, that you're managing the connections between the applications themselves, right? Which is a little bit of traffic management, I would think.
Yeah, because whether it's on the networking side or on the server side from VMware, they all have what's called a microsegmentation solution, which is exactly what you're referring to from a security perspective, where you can microsegment the network by application, or depending on your security requirements, you can deploy different solutions there.
Right. So another thing that's interesting that I'll pick your brain on, right, is, and you might not, we just introduced this at VMworld this year, is this notion that, so NSX runs on top of ESX, our hypervisor, right? And so you generally have to do this on a server, which is fine. You designate a server, or you designate a VM on a server to manage that workload, right? Where you're doing the layer 2 overlay is sitting. NSX runs on vSphere. They're now, or ESX, our hypervisor, they're now talking about putting ESX in the network controller. Some of these fat network controllers, you can put ESX, the hypervisor, right on the network controller, then run NSX on the network controller to do the network routing without ever having to put workload on the server itself. Which is interesting, right? An interesting concept, right? Where you offload, because all of this ends up being a software stack for your network cards or your network connections. They're basically taking the requirement of having ESX, which would normally be an Intel CPU based workload, off and putting it on the network controller, basically putting it that much closer to the network infrastructure directly, so that your server that's running your big loads isn't impacted at all by the layer 2 overlay fabric management, I guess I would call that, which I think is the best thing that I've heard, which is what we're going to talk about. The November 6 event is going to talk about, one, the overlay, typical NSX, right? 2, security, and 3, the actual endpoint management for microservice applications, and then 4, how to move that whole stack right into a network controller, right? That's, which I'm not sure what the advantage of that is, but I guess that's the architecture. So, and there's quite a lot of buzz around it, but I'm not sure whether that's just buzz or whether that's real. But we call that Project Monterey, right? Which is running that whole stack on a network controller. Right?
That's interesting. I believe that's part of VMware's evolution to streamline the solution.
Right. Although I'm not really sure, but it certainly makes the whole networking stack dedicated to the network controller, right? So you're almost in the physical switch business if you've got a network controller that does all that work and you've moved it out of the server, kind of, because it's now deployed on the network controller, right? Versus,
Yeah.
The overhead of anything with routing or switching from within the NSX stack is now out on the NIC itself. And because vSphere is effectively running in a container, one of the things that I believe that's out there with Monterey that would also allow you to do is when you would need to upgrade the host in certain situations, that you could take the running instance of ESX that's traditionally running on the main CPU and temporarily shift some of those functions out to the NIC, and then do the updates that you'd need to do, and then run that, and then shift it back, or in other words, move the spin up another node, and then move it back to the CPU.
yeah. I couldn't get a sense of whether the is this main CPUs running in a hypervisor in a VM, and now the NIC is controlling that workload that's on the main CPU. Like, it's kind of hard to get your head around whether that's what they mean or some other. I know that putting ESX there and running NSX there and managing all the network overlay makes sense. But then what I still struggle with is the CPU running bare iron, right, on OS directly, or something else, because I've heard comment like, well, if we're running, if you're running a big database, you don't want ESX in the way, or you don't want any kind of network NSX for sure in the way. But I can't tell whether they're really talking about managing bare metal also, or whether you're running VMware ESX on your main CPU, and then you can do workload movement like what you just described, right? I don't know, right? So.
That's interesting. I'm not quite on top of that. So are you saying actually the change here is to run, was it ESX or
ESX, yeah, I think so. ESX
on the NIC card?
On the NIC, yeah.
And what, just the ESX or the NSX controller piece itself as well?
And NSX on top of that. So yeah, ESX hosts NSX. So yes, ESX and NSX all on the NIC. That then gets you capabilities, right, on the NIC itself, which means you're no longer dependent on the CPU. You can let the CPU do whatever it needs to do, right? And you're not, yeah.
And is this with this, is this a special NIC that you've partnered with somebody, or how did?
I believe they've announced. Yeah, I believe we've announced some number of.
Melonix is a partner, I believe, and as well as Intel. There is a limited number of boards out there that have come out of testing. I don't know if anything has met the HCL as of yet, but obviously they've been partnering and working with certain key vendors
on the
to
chat.
get this out there.
Their chat, they were saying we partnered with NVIDIA as well.
NVIDIA, yes, sure.
Well, that's interesting. So there's a lot of offload from the CPU to the NIC cards.
Right. And so that puts VMware in a pure networking play, because you're just in the network card itself, and we're working with the card vendors. And now you just have a whole software SDN payload that sits outside of the CPU. Don't need the CPU connection. You're just running it in the NIC.
And then the idea is to have the CPU just dedicated for apps.
Yes, I get the impression there were large database vendors and others that didn't want to see the NSX running on the physical CPU. This NIC solution solves part of that, right? And to Matt's comment, you get to do upgrades and other things while your workload, I don't know how that works, right? But yeah.
That's interesting. So with typically on the NSX side, you have you need some kind of redundancy in HA from a controller perspective, right? So you could implement, because typically you need like at least 2 or 3 somewhere in your network for failover. So I'm assuming you'd have this capability on other NIC cards on other servers to give you the HA piece.
Yeah, it really depends on where you want to look at your failure domain, right? Do you want to look at it with intra-host or within intra-cluster
Okay.
and your level of fault tolerance?
And I was thinking from a big picture perspective, if you have 2 data centers now, and the old model was to either have some kind of HA across data centers.
Sure.
And so now with the model changing to NSX on the NIC card, I'm assuming the same HA rules that you had before would apply here as well, with some kind of communication now using VXLAN between the NSX controllers and the 2 different data centers or campus networks, that sort of thing.
Yeah, and there's a lot of buzz around that, and buzz around this move that we're making, and some people actually label it as big as virtualization was for the CPU, right? That if you put the NSX layer in the network card, it gives you some really interesting ways to build out your network infrastructure that are quite different, but have advantages, right? So, and that's part of what we're doing in the November 16th. I'll say it again, November 16th launch, where they're going to come in, and they have some customers come in, and I know I've seen it, so I know what it's there, and I know I can't say too much about it, but I know there are going to be customers that are going to talk to it as well. So pretty interesting. And then I think they're going to talk about also security and modern apps and how they're going to do that as well. So it is interesting to see, next generation. Question for you, Merv, coming back to Cisco, because they are still a big vendor. they're still a 40-50 billion dollar vendor out there, and clearly they're going to still sell switches, right? Because you need the underlay, right, as you say.
Yeah.
I think they're going to also probably move into this space as well, right? Or if they already have their own SDN solutions.
Yeah, Cisco solution is essentially the APIC, or Application Policy Infrastructure Controller. So there's a big difference between the Cisco solution and the VMware solution. With Cisco, they follow what's called the group policy model. So there's an underlying protocol difference between the Cisco implementation and the VMware implementation on the SDN side. So with Cisco, they actually use OpFlex and this concept of network policy. So from the Cisco controller, the APIC controller, you're actually pushing out a network policy to each switch in your network. And then once the policy is pushed out to each switch, then the data forwarders in this case are actually independent in the sense that once they have that policy, they can function as is without really having to communicate with the APIC controller.
Right.
So
it just reminds me of Yellow Pages in the old days of NFS way back, right? Like where you're just managing the policy and distributing a policy out to policy servers, and then can manage out to the individual network switches that then run policy, and then you're just doing policy updates on a regular basis, a push model.
Yeah. Whereas in the NSX solution, I believe they use what's called the OVSDB protocol, where NSX uses this OVSDB protocol to talk to all the other data forwarders in the NSX SDN model. So with Cisco, there's advantages to both solutions, but in the case with the APIC solution, it follows the network policy with endpoints and endpoint groups that you build within your network. And that's, I don't believe that's changed. What's interesting about the Cisco solution is I believe they can also interface with the VMware NSX controller. And there are situations where there is interoperability between an APIC controller and NSX. So whether NSX runs on the NEC card or the physical server itself, the old solution, I don't think that would matter. But again, these are two different architectures. VXLAN is still common between them in the sense that it's still used to build the network from a layer 2 and a layer 2 extension perspective. But from a controller perspective, there are some underlying differences between the two solutions.
Got it. Next topic for me, and I always do this on our podcast, is I always talk a little bit about the cloud vendors, or what we call the hyperscalers, right? Which is Amazon, Azure, AWS, AWS, Azure,
GCP.
yeah, Google, and even IBM and Oracle and other big cloud vendors. There's network connectivity that goes to the cloud vendors. Have you seen any exposure to this? Are they choosing sides? Are they basically, running, allowing you to build networks into their network? I don't know if you've experienced any of this, Mervyn, whether that's something you're aware of, but I think that's going to also hit is, connectivity to the hyperscaler cloud vendors is going to be important moving forward, because everybody's managing, these connected workloads to the cloud vendors. And so I wonder how that's going to play out.
Yeah, it'll be interesting with IBM and the Red Hat acquisition.
Sure.
That's because, Linux is playing a big part in the future of all this.
Right. And how the client OSs interact with the network fabric as well. Right?
And not only that, it's the container-based solution versus what you guys do.
Right.
Because for the most part, containers are free.
No, they're not. They're not free. No, they're very expensive. It's a lot of money to run those things, right? Again,
just to give you an idea, with the new Cisco switches, it's all container-based.
right.
They tend to use containers a lot. That's how they. So with the new switches, if you want to spin up a function, a software-based function for security or anything else, you just spin up a container on the switch, because with NXOS and all the newer switches, it's all Linux-based.
Right.
The underlying operating system, right?
Yeah.
So that's the direction with most vendors, not just Cisco. It's the same with Juniper and Arista. It's all container-based. And that's how they see this evolution now on the networking side, to provide software-based functionality.
Right. The container infrastructure, right? And container infrastructure just makes network, need requests, and you provision right out, right, and you do that at the container layer. Yeah.
Yes, that's what they call programmability of the network. Right. So you talked about how this has all changed and how we're going to pay for all this. So with all the major networking vendors, they're all moving towards a software-based model and software-based licensing, in the sense that if you want a feature now, you spin up a container and then you pay for it.
Right. Yeah.
And so the traditional, in the old days when Cisco used to sell software, you
bought it by the switch, right? Yeah, it was bundled in with the switch.
It was bundled into the switch, but you paid a fee for like other additional features like SNA or AppleTalk or stuff like that.
Right.
But now the model has changed, and then because they're going towards the software-based selling model and programmability of the network, that's where you're seeing the way they sell things different.
Yeah. Are they selling also based on traffic amounts, right? Or volume? Like, or is it still just feature based and capacity of the service, but maybe not, gigabits across a
No, not gigabits. It's more licensing. So for example, with the security licenses, like IPsec, for example, you pay for either 100 tunnels or 200, that sort of thing.
So
But
it's
otherwise,
reality based. It's not traffic based yet.
no, no.
Yeah, I hate traffic based charging. Right, like
I mean,
how much traffic you're going to have, and then
well, if you're a telco, it's different because you charge based on usage,
sure, yeah,
traffic shape, your connection depending on how much you need. So that's different.
right.
So Mervyn, to that end, I mean, I think of where we progressed to, like in a small to medium sized business where if you were on the smaller end, you bought some 2950s and you put them out at the edge. And if you were getting really big, you put a 4,000 or a 3,000 series core switch in and tied it all back and maybe stacked them. Or if you had a core switch that, if you could afford it, you had two of those. But we hear a lot about 5G, and we hear about a lot of how this is now going to, bring true wireline speeds out to the edge. So do you think it's conceivable within, I don't know, a 5 to 7 year time frame where again, that small to medium sized business that we're not even worried about switching and routing at the edge, where it's all just going to be a true telco defined software layer where the connectivity is built into the device. And if you need to have a device talk to something else on the LAN, that's going to be a price point. And if you want microsegmentation, that'll be a price point. And then if you want security, and it'll just add on to these telco services, because everything will eventually be coming out as a DAS service. I mean, where do you see, how does this progress, or where do you see this for the average small to medium business of what's the need for the local LAN anymore and local LAN services where it could be now delivered as a monthly or annualized service charge from the telco?
I think in both in North America, both in the US and Canada, and I believe in Europe as well, the telcos they've all evolved their network. And now they're offering exactly what you described. So for small businesses, for example, they'll they'll put in a smart modular switch that gives you these capabilities that you can easily upgrade to with just like a software add-on in the CPE box from the telco. So from a small business perspective, all you would need is traditionally you would have your switching infrastructure, one or two 2900s, what have you, in the local site connected up to just a pipe, a dumb CPE. Whereas now the telcos have changed that in the sense that they may offer more than that. So they'll give you, you would just need to go to the telco so you essentially tell them I need X number of ports with this and this feature, and they can deliver that to you. This way, you have no requirement for a network admin or any kind of support infrastructure down at the small business end. It's all handled through the telco.
Is it reasonable to assume that wireline connectivity or Ethernet connectivity at the edge will be going away, or it will be a true, point-to-point connection from the device to the telco?
Yes, because what a lot of the telcos, the way they built the network was using BGP, because that was the protocol that allowed you to scale effectively across, like, North America or within multiple countries, that sort of thing. But now what they've done is with all the telcos, they have layer 2 capability within BGP with EVPN. So for them to, but for the telcos, it was a big task to upgrade the entire network because it's a slow process that they have to do. So typically you upgrade the edge, then you gradually move to the distribution and the core. But once all of that's done, you could essentially spin up a VXLAN, a layer 2 pipe
Sure.
between any two sites.
Mm-hmm.
And that's all done through a point and click GUI that allows you to do that. And this is all done through BGP and EVPN, Ethernet VPN. So in
And at
later,
a telco provider, it's just another service that they could charge for, right?
exactly. So that's the evolution on the telco side. Here in Canada, I think they're almost ready to offer that service. They've had trials, and because it was a big process. Because on the switching side, when you're dealing with telcos, they're service provider switches, quite different from the Nexus 9000s. So these are the CRSs and
Sure. It's a whole other level of redundancy and reliability, and
exactly.
brings 5 nines really into focus.
Exactly. And it's not a small upgrade to move towards a version of BGP that supported EVPN. So it's a gradual process. So I think eventually all telcos will be able to support layer 2 over BGP and provide that service, and giving all customers much more flexibility in terms of whether they just need pure internet connections or just point-to-point layer 2 extensions, that sort of thing. So in the case of VMware with this NSX type deployment, you could theoretically deliver that through a telco providing the layer 2 extensions now, right?
Sure. I mean, we have it at our dedicated telco BU that I'm sure is working on just that.
Yeah, or you could just do the traditional way where you just have layer 3 BGP and then just have VXLAN endpoints defined between the two NIC cards or between the two servers, the VMware servers. So there's a lot of possibility going forward. And then, with all the telcos, they're also looking at network function virtualization, NFV, right? Where what Eric was just describing about security and add-ons to the network. So with the future capability of these telco switches, you could provide NFV type functionality on the CPE. So you want to just deploy security.
Yeah, voice QoS,
QoS,
introspection on packets between microsegmentation. Sure.
Yeah. So
and that could be between endpoint devices within, let's say, that layer 2 level, or anything between an endpoint device and a cloud provider. It really would just depend on the customer requirements at that point, would it not?
exactly.
Yeah.
And don't forget there'll be a fee per service.
Absolutely. Absolutely.
A sizable,
Per service, per month, per ingress and egress, right?
well, everybody's to live and everybody has to make a bit of money, right? So, but there's a lot of evolution on the telco side with what's happening on the BGP side and BGP extensions for layer 2, and then just traditional VXLAN, that sort of thing. And then what's interesting is BGP, for the most part, with MPLS, you guys probably know about MPLS and traditional
Sure.
VPN type connectivities. Now you can do the MPLS thing, you can do the EVPN thing with a switch that has the right operating system to give you all of these features. So MPLS is old, and that's that's been there for a while. The trick was to introduce BGP EVPN to the switches in your network on the telco side to give you these layer 2 extensions. And that's where all the activity is right now. So in Cisco's case, and in Cisco, Juniper, Arista, they're all big on BGP, multi-protocol BGP and EVPN, because that's their control plane for giving you layer 2 across the switches running BGP.
Right. Makes sense. Makes sense. Interesting. The last thing I'll talk about is IT careers in general, because we are a community podcast, and I'm wondering how long network architects and network managers are going to actually still have a job, right? Because some of this consolidating back into cloud as services, sooner or later, we're all just going to be button pressers, right? Where you're just going to get the whole fabric laid out for you, and you're just going to click. And some people in chat are actually, mentioning that, like, yeah, most people's networks experience is like how to connect a router in between my home network, and really it looks like how what's happening to the career is IT practitioners merging into IT network managers, because all of this just becomes a software layer, right? And then software layer is all controlled by mouse clicks and what the software actually will do for you, versus the days maybe 15 years ago where it was all very separate. You had hardware, you had rack and stack, then you had the OS that you manage, the Cisco OS. And so where do you think some of this is going?
I think what they're hiring today are all grads with programming backgrounds. The hot thing right now is all Python, Ansible, that level of programming. Because if you look at what we didn't discuss here is what's going on the automation side. And on the automation side, it's all Python, Ansible, Puppet, Chef,
Right.
those kind of tools, right?
DevOps control, infrastructure control. They're embedding that in and doing the whole infrastructure control just as another DevOps tasks in Puppet, Ansible, Jenkins, those guys, right?
Exactly. So that's a big career path for grads right now.
Could even argue that there will be Kubernetes control, modules that will just control the fabric as well, right? Like,
and the other big thing is data analytics with machine learning and that direction.
Yep. We had some data analytics, machine learning guys in from VMware, because now that's growing. NVIDIA's doing, so if you look at NVIDIA's doing networking, NVIDIA bought ARM, right? CPUs, NVIDIA, has a GPUs, and so where they're doing machine learning. So they're actually in an interesting place as well, where this is all coming together. So data analytics, modeling, learning, all of that coming together, because networks are driving data. It's all software. It's an interesting time, right? And careers will change, based on automation. And you're right, that's an interesting perspective where automation will become the key of managing your networks, because there's such big scale to where what you're really doing is worrying about automation and letting the cloud providers and the software stack providers provide you with feature sets with APIs that you can control using automation.
Yeah, because if you look at, remember you mentioned the SDN controller. With the SDN controller, whether it's NSX, Cisco, Juniper, Arista, there's northbound APIs and there's southbound APIs, right? Southbound to interface with the network, and northbound to interface with all their network management tools, the applications, what have you. And guess what they use? Python.
Right. Sure. Yeah.
So that's hot. But the other thing that's not mentioned here is, if you look at the Googles of the world, they follow the open source path. So with Google, they have white box switches, and they do all the programming themselves.
Interesting.
So you can buy a generic white box switch, and then you're following like OpenStack and Neutron and OpenFlow.
Right, and that's really how Kubernetes spun out of the same thing, right?
Right. So
infrastructure that they built.
Yeah. So if you're looking at a software startup, they're not looking at buying a vendor switch with this Juniper, Arista, Cisco. They'll buy a white box switch and then use open source and program the switch and go that path.
Or in our case, if you've already got vSphere throughout your data center, now we have NSX and Kubernetes embedded into vSphere, so it runs right in the hypervisor, and then you can also control all that as well. So for existing data centers, that's where VMware's moved into that stack, right, where we put it all together. Then you can build Kubernetes control infrastructure right controlling everything at the vSphere layer. And so
Avi for load balancing that now is incorporated into NSX.
Yeah. because
Well, we're running out of time here, top of the hour, right? We've been at it an hour, and Mervyn Fernandes, it's been fun. Yeah, Matt, any last questions for Mervyn before we, wrap things up? Because we are at the top of the hour.
This will be a topic for a separate podcast, Eric, but I wanted to see Mervyn's take on IPv6 adoption and why it's lagging. But I think that's a separate sidebar. But I do appreciate Mervyn being on. He has immense experience. I can tell that at the beginning of the conversation here before we had started to record, Mervyn was telling me about his punch card programming experience and acoustic couplers. So a gentleman that has certainly seen the gamut of the IT implementations and networking and whatnot. And I very much appreciate him being on and sharing his knowledge with us and the community as a whole.
No, I hope it was useful. I tend to ramble on sometimes, but
No, it's been great. It's been great. And again, we're promoting the network event next week. And so it's always good to just have some topics on that we don't normally cover here. We don't spend a lot of time on networking. We have a special edition podcast that we promoted throughout the week to where we had the NSX product manager come in and do a little bit of overview of NSX and the history of NSX and where it's going. So if you guys are listening to the podcast on iTunes, you can check that out. We published that last night. Special podcast with the NSX product manager. Go check that out. Go register for the NSX event. Mervyn Fernandes, always great to spend time with you and talk network chat. You always throw protocols in that I don't understand, and I always roll my eyes and go, this is so much. I'm glad that it all comes down to Python because I can get a handle on that. So I'll stay in the game for a little bit longer, maybe another 10 years of my career before I'm just ready to hang it up. I still got kids in college, so I have to worry about that as we all do. Matt, thanks for the question. What was the question? Repeat the question because I want Merv to take a 1-minute answer to your question. But
IPv6 and why it's been slow to adopt.
I've had that same question. Why IPv6 is such a slow adopter? Maybe because IPv4 just keeps working and we don't really care.
no, the underlying reason for IPv6 was the concern that you're going to run out of address space on the v4 side. Has that happened?
Apparently not. Maybe we just recycle numbers. I don't know.
So unless you're a research network, so a lot of the research networks in the US and Canada have built an IPv6 backbone. But unless you have a need for IPv6, the general answer is,
yeah, everybody's running on their internal networks are all 192 networks, right? Like nobody's actually consuming that many on their inside side, and then forwarding and all that.
Yeah, unless there's a serious concern with depleting address space,
right?
And you're actually seeing it until there's an actual need for it. I think because when you think about it, it's a huge effort for both the telcos as well as customers to migrate to an IPv6 based network. And the easiest thing is, if you have a V6 backbone, just tunnel the V4 in your V6 and you're done, right?
Right. There you go, Matt. That is a short answer. You're right. An entire podcast just on the subject.
We can talk in more detail about that. No problem.
I'd love to.
Yeah. All right. Well, we're at the top of the hour. Thanks a lot for guys on TalkShoe. Matt, let's see. Tony Foster, I know I'm not even sure we have you live anymore because I'm getting error pop-ups on my TalkShoe live. Oh, there you go. No, it seems like it's
still here.
Yep. Cool. I don't think we did any we always do a little bit of barbecue at the end of the podcast. And I know Merv is a big barbecue guy. He goes out in his backyard and barbecues now and then. We're coming up to Thanksgiving. So, you got the barbecue turkeys that we're going to have to all figure out how to do if you're going to do one. Anybody got any cool barbecue recommendations for the week? I don't know if I have anything.
Mm-hmm.
I don't have anything.
Don't
Yeah.
have anything. Nobody has anything. We're all just going to take a.
Oh, this is not good. I mean, I think we might need to do an audible here on some recommendation. No barbecue report is just a shame.
I packed my barbecue up because winter's coming.
Takes it down. Indoor barbecuing. There you go. Got the George Foreman grill on the
Yeah.
side. Right there you go. Well, all right. We're at the end of the hour. It is lunchtime here in California, so we're going to go get some food. That's why we do the barbecue report at the end of the podcast. Mervyn Fernandes, thanks a lot for coming and joining our ecosystem. We appreciate it.
Oh, no, thank you very much. And everybody, keep well and stay safe.
Yes, everyone do that. We will be back next week where you're going to be covering Amazon's RDS, AWS RDS. So VMware resells the RDS database product that hosts on Amazon. We got the product managers to come in and talk about it because Amazon reInvent is coming up. We're going to actually have VMware code sessions in our virtual booths at Amazon reInvent that kicks off early December. I'm going to do some Raspberry Pi sessions, going to recruit William Lamb to come in and do one on ESX on Raspberry Pi 4 and ARM. So ESX on ARM on Raspberry Pi 4. So pay attention to that. Next week, Amazon RDS. We're going to have the product managers in to come and talk about that product. And we're ramping up for the network launch and then following that up with Amazon reInvent and all the stuff. We have a VMware virtual booth that we're going to be talking about as we move forward on the podcast. Thanks a lot for being here. Everybody have a great week, and we will see you again next week. Thank you. Have a great day.
Thank you.